Hello and welcome. My name is Tarek Radwan. I'm Product Marketing Director for Artificial Intelligence here at Juniper Networks, and we're going to have a quick discussion now about the fundamentals of AI. You know, when it comes to networking, AI has become very, very popular as of late. So, Bob, I want to ask you the first question. What exactly is AI and what are its salient characteristics?
Yeah, Tarek, what I usually tell people is AI is ultimately the next step in the evolution of automation. With a slight twist in what we used to do in the past when we automated things, it was very deterministic. We wrote scripts and they basically did the same thing day in and day out, and you really didn't think out of it. What we're really building with AI is really more about cognitive reasoning now. We're starting to build AI solutions that act more like a human and actually change behavior over time. It's almost like hiring a new intern, right? You bring on that intern, you bring on that AI assistant. The first thing you have to do is understand their skills, correct? And after you do that, you expect this person, this intern, this AI assistant, to actually get better over time as it starts learning. So that is a fundamental difference between what I would call AI in the past, very deterministic ML type of algorithms, and now we're moving to these much more deep learning type of algorithms that really have the behavior of cognitive reasoning and start to look like a human that's actually learning things as you actually interact and use it more.
And in our industry, when did AI exactly become important?
That's an interesting question because you look at my experience, back in the 80s when I did my master's, I was actually doing neural networks. So when did AI really become a big thing? If you look at Google and the Google searches, AI ML took off around the 2014 timeframe. And if you think back what happened back in the 2014 timeframe, that's when we had a convergence of several things coming together. We had open source code coming together. We had many more packages making it easier to develop these algorithms. We had these cloud models, right? AWS, Google Azure, where compute and storage got a lot cheaper. So I think we saw kind of a certain thing happen in 2014 where we saw AI startup between a combination of cloud technology and really the open source community bringing tools together and make it easier to actually build bigger solutions. And probably the other big thing, especially what we saw with ChatGPT, is we found out compared to the models I was doing 20 years ago, now we have deep learning models with 100, 200, 500 billion weights in them, right? These models are getting on the size of your brain now. And that's the other thing that's happening now in 2014 so lately, is the models have gotten very large and they do much more interesting things.
Let's double click a little bit and maybe explain in basic terms. What exactly is ML, machine learning?
I would say machine learning has been around for decades. This is probably things like logistic regression, decision tree algorithms. These are algorithms we've been using for 20, 30, 40 years. So that's what I call machine learning. What's really changed is really what we call deep learning. This is where we're starting to use much more complicated models with many more layers, many more weights. This is what brought transformers and ChatGPT to life, is these really deep learning models that are continuously learning on a lot more data. And so similar to what we were doing with Teams and Zoom and Marvis now, we're basically bringing in deep learning models and a lot of continuous learning into those models. And that what brings out this non-deterministic behavior where these models learn and basically get better over time.
Now, we've heard about these terms of unsupervised learning versus supervised learning. Can you kind of explain what that all means?
Yeah, supervised learning is like what they did with ChatGPT and transformers, right? They took all the data off the internet and they trained a model to predict the next word. Similar to what we're doing with Zoom and Teams, where we're taking tons of Zoom data and building models that can actually learn the Zoom and Teams performance. That is supervised learning, where you have a whole bunch of labeled data that you're trying to learn to predict something. Unsupervised learning is really what we did with location, where I don't have any labeled data, and where we're trying to learn the path loss model for every mobile device in an area, where I basically have no labeled data, but I'm learning to predict that path loss model for all devices in your network to make a better location estimate.
And just to cover a bit more on the AI alphabet soup, can you maybe touch on neural networks and maybe deep neural networks?
Yeah, these are subtly the same. When you look at the original thesis on neural networks, it was pattern after your brain. right? If you look at the neurons inside of your brain and how you learn, you're basically analog weights. So that original neural network model was basically building up layers of weights that would basically be able to be trained to predict something. And as I mentioned before, what has really changed now is these deep learning models like transformers that we're using with ChatGPT. This is what we call assistant attention-based transformer learning models. These are really very large neural network models now with 175 billion different weights inside of them. So that's the subtle difference between neural network and what we call deep learning. Deep neural networks is really around the size and the amount of weights we have to train.
Since you did mention ChatGPT, can you explain what is an LLM?
Yeah, these large language model is what got everyone's attention about a year or so ago. And it's made our lives a lot easier because I can tell you there's a lot fewer AI skeptics out there once they actually use ChatGPT. So these large language models are based on a model called transformers, attention-based transformers. And this is where they're basically taking tons of data. They're taking basically everything on the internet and they're training these models to predict the next word. So you can think of this as a conditional probability where I take the last 500 words to predict the next word. And this is where these large language models are starting to sound like a natural human language. And even more, they're starting to look like reasoning. So large language models are really an amazing thing coming out in the networking right now, both for how they sound like natural language humans and where they're actually starting to have reasoning capabilities. And this is going to play into helping us troubleshoot networking going forward.
Now, is this the same as generative AI or Gen AI?
Yeah, I think Gen AI and LLM are basically synonyms for the same concept here, whether it's a large language model or generative AI. Large language models usually apply to some sort of language. You can technically take these same attention-based transformer models, these Gen AI models, and apply them to other use cases. An example would be instead of using language, we can use these Gen AI models to actually translate text to search, SQL, Elasticsearch. This will basically enabling customers to actually start to explore their network data and replace some of these BI tools, making it easier for customers and enterprises to explore data in their databases.
I can't help but ask the question, how has Juniper used or is using Gen AI today?
Yeah, so what we announced last year at Mobility Field Day was basically integrating Gen AI and large language models into our Marvis. And the first phase of this is really around public documents, making it much easier for customers and support teams to get specific answers out of hundreds of thousands of documents. So this is phase one of taking Gen AI and LLM and making it easier to get both the answer and the documents and the information you're looking for.
Now, just to quickly go back to basics, what exactly is model training?
Yeah, so every model is slightly different and depends on what problem you're trying to train. But you could think of every model basically has a set of training data for supervised learning that we talked about. So let's take Zoom and Teams, for example, right? I have a bunch of Zoom or Teams data that I have to join with my network feature data. And then I want to train that model once a day, once a week. And so when we look at the training model, it's basically the problem you're trying to solve. With anomaly detection, we're basically training models every night and every day on the last 3 months of data. And that's for anomaly detection, making sure we look back in time, trying to predict anomalies for the next 10 minutes. So that is the training. It's slightly different whether we're doing self-supervised or supervised, but almost all deep learning models have some sort of training schedule assigned to them.
Thanks again for your time, Bob. That was really informative.
Yeah.
Appreciate it.
It's good to be here, Tarek. Always enjoy talking about AIOps.